All right, here's a nice question. You need to solve this inequality. And inequalities you can treat very similarly to an equation. So you do the same operations. They apply for an inequality. The only thing you have to worry about in the end is if you divide by a negative number, you have to switch that inequality. Okay, so the first thing that bothers me about this equation is this fraction. So I can use the I hate fraction rule to simplify this to get rid of fractions. So what you do is you find a common denominator. So this is one term, this is one term, and this is one term. So I look at all the denominators, and the common denominator would be a 10. So I'm going to take that equation, or inequality, let me rewrite it. 9 over 10, 3 plus 6x plus 1 greater than or equal to 16. So I'm going to multiply each of those terms by that lowest common denominator. So I'm going to times that by 10, this by 10, and this by 10. Now in this first one, it might seem a little, you might think that you have to multiply that 10 by this and this, but you just have to multiply it by one thing. For example, if I have 2 times 3 times 5, I just go 2 times 3 first and get 6, and then 6 times 5 gives me 30. But I don't multiply the 2 by both of those things. I'm just multiply it by 1, and then I multiply that total by the other thing. So I'm just multiplying this 10 by this first fraction. So the 10 on the top and the 10 on the bottom both cancel each other out. So I'm left with 9 times 3 plus 6x. In the next one, I just have 10 times 1. That'll be 10. Greater than or equal to 10 times 16, 160. Now let's get rid of the brackets. So I'll use the distributive property here. So 27 plus 54x plus 10 greater than or equal to 160. Now let's collect like terms. So let's move the 10 and the 27 to the right side. So 54x greater than or equal to 160 minus 27 minus 10. I think I'm getting all that right. Okay, let's go up a bit. Now, so I have 54x greater than or equal to 123, I think. Is that right? 160 minus 27. So that'd be 3, and then minus another 10. 123, yep. And then divide both sides by 54. So x greater than or equal to 123 over 54. Now I think you can divide both of those by 3. Oh, also notice that we divided this by just a plain 54, not a negative. And so I don't have to switch this inequality. So the x is greater than or equal to, let's see, 3 goes into that, I think 41, and 3 goes into that 8. And I think that's as simple as it goes. So x is greater than or equal to 41 over 18. I can make that into set notation. So all the x's are as x is greater than or equal to 41 over 18. If I put it on a number line, 41 over 18 is 2 something. So 1, 2, 3. So it's somewhere in here. And it's greater than or equal to, so it's from here on up for forever. So in integral notation, I'd put a square bracket because it could be equal to 41 over 18 would be the smallest number, and infinity would be the largest number. And infinity always gets a curly bracket. All right, hopefully that helps you with that question. Lots of places where you can go make a mistake, and I might have made a mistake going through. I don't think so, but I could have made a mistake going through. Hopefully that helps.